Запис я вже почав, якщо що.
Дякую. So, dear colleagues, I'm glad to see you on opening of our PhD symposium of conference ICTRI. I would like to say some introduction before we start presentations and discussions of your researchers during all our day. So I would like to start and to introduce our event, which is under umbrella of our ICTRI conference. Just a second. Could you please to say me, did you see a title of presentation, PhD Symposium at ICTRI 2023?
Yes.
Okay, thanks a lot. So I would like to present our chairs of PhD Symposium. The PhD Symposium at ICTRI this year were prepared by Vera Lubchenko from Hamburg University of Applied Science in Germany and Odessa Polytechnical National University Ukraine and Vitaly Kobets from Kherson State University Ukraine. Our PhD Symposium has the main goal as to provide an expert environment for presenting ideas and early results of PhD projects or other research aiming to be developed in PhD projects. Our PhD Symposium has two main tasks. Discussion forum for young researchers who are at the beginning of their careers, such as PhD students or young researchers from industry. And second, to discuss their research ideas with their peers, supervisors, and senior researchers working in the field what are within the scope of ICTRI conference. You can see main topics of our PhD Symposium, and during this year we have many submissions which was applied in data analytics, in machine learning, for digital societies, software development, etc. So, if we consider, for example, history and perspectives of PhD Symposium from beginning 2017 till 2023, you can see dynamic of these submissions. As you can see, the second column demonstrates number of submissions, and first column demonstrates accepted publications. As you can see, in this year we have approximately twice more submissions to our PhD Symposium and 8 accepted submissions. As you can see, in previous year we have approximately 2 times less submissions, or on 1/3 less, and number of submissions vary through these years. And we are glad that nevertheless on current circumstances, which is linked to war of Russian aggressors against Ukraine, we have possibility to continue our research activities and our conference. As you can see on this slide, the accepted percent of papers decreased from one year to another one. We start from 71% of accepted papers and even 78% till approximately 50%, and last 3 years we have no more than 1/3 of accepted papers for our PhD symposium. This year, results of accepted and presented papers will be sent to Springer volume to publish these results in post-proceeding of our conference. So this year, as you can see, smallest percent from all before, during strong requirements of both organizers of conference, PhD symposium, and Springer production, which as a rule includes only results which don't exceed 33 or 1/3% of all submissions. So on this slide we demonstrate main results. So 26 submissions this year, 8 submissions was accepted, and acceptance ratio near 31%. Total number of reviews is 80. And the main results is presented on EasyChair service. So from general statistics of PhD symposium, each paper was reviewed as a rule by 3 PC members from international committee of our PhD symposium. For some papers who need extra expertise, were invited 1 more experts, and 2 papers were reviewed by 4 PC members. And in average, each paper includes 3 authors per 1 paper. As a rule, 1 or 2 first authors is a PhD students or master students or postdoc students, and 1 or 2 scientific advisor if number of students exceed more than 1. So the number of PhD symposium program committee members is 28. So you can see geographical distribution of our PC member from 14 countries worldwide abroad. And it gives us possibility to get only best papers which were accepted, and this year only paper who was accepted by all members of program committee were recommended to accept and present their own PhD symposium. As a rule, number of submission per author, as a rule, it's a 1, but we have 4 submission simultaneously prepared by 2 authors, and 3 submissions also by 3 authors, and 1 submission where 4 submission where was presented same author. Numbers of authors per submission, as a rule, 2. The first one is a PhD student or master student or postdoc student, and the second one is a scientific advisor. So 4 papers was submitted only by PhD students, and some papers were prepared by author by more than 2 authors, which include more than 1 PhD students and 1 and more scientific advisors. So the schedule of PhD symposium includes 3 sections. The first section will be start soon, and chair of this section is Tommaso Federici. After some break from 3 p.m. till 3:30 p.m. we will start second section. The session chair is Vitaly Kobits, it's me. And the last session, after some break, after 30 minutes, from 70:30 till 80:30, using East European summer time in Ukraine, will be Tusef Hussein. So we have some rules for our offers. and logic of our presentations. By default, microphones off during all sessions. Participants are turned off. All questions should be written in session chat or by microphone. The presenter is strongly suggested to use the slides what help him or her to answer the questions, and the session chair selects the questions to presenter. Link to the online session, I hope you know about it, because before our session you have possibility to have a look the logic of our presentations. Thank you for your attention, and let's start. As I see, you maybe our first session chair maybe have some technical troubles, so we can start taking into account conference program, and just a second. And in our case, we will start. Just a second, and okay. Our first presentation by Alexander Tereshchenko and Natalia Komleva, which was titled Vulnerability Detection of Smart Contracts based on bidirectional GRU and attention mechanism. So you're welcome. You have 50 minutes to present your paper and 15 minutes to answer and question sessions. So you're welcome. Please, let's start.
Good day. Do you see my screen?
Yes, we see.
Good day. First of all, thank you for the opportunity to present our work at this conference. My name is Alexander Tereshchenko, and I am a graduate student at Odessa National Polytechnic University. The topic of our work is vulnerability detection of smart contracts based on bidirectional gated recurrent units and attention mechanism. In this presentation, we will start by exploring the relevance of our research. Then we will delve into widespread vulnerability found in smart contracts known as the reentrancy vulnerability, which we will detect using our method. As well, we will explain how we represent smart contract code as vectors for utilization in a neural network. To shed some light on our model, which is built upon a bidirectional gated recurrent units with an attention mechanism, we will provide a brief overview of these concepts. Additionally, we will unveil an architecture of developed model. Next, as the training process of our model involves the use of a dataset, we will also discuss how we created it. Lastly, we will outline the metrics employed to assess the model's performance and summarize our work. So I would like to start with the definition of smart contracts. Smart contracts are self-executing agreements with the terms of the contract directly written into the code. They're deployed on blockchain platforms and are becoming increasingly prevalent in various industries, including finance, supply chain, and healthcare. Smart contracts are immutable once deployed, making them highly secure when implemented correctly. However, coding errors and vulnerabilities can lead to severe consequences, such as financial losses and data breaches. Manual code review and auditing may not be sufficient to detect all vulnerabilities. Automated vulnerability detection methods, such as deep learning, can complement traditional approaches to identify subtle issues and improve overall security. Unfortunately, existing methods based on deep learning are not accurate enough. Thus, research in this area is relevant. Our work is aimed at detecting the most common vulnerability of smart contracts, namely the reentrancy vulnerability. According to the Solidified platform, it has been revealed that 17% of all identified vulnerable smart contracts has the reentrancy vulnerability. This underscores the critical importance of promptly identifying this specific vulnerability. Reentrancy occurs when a contract's function is called multiple times before the previous call is complete. This leads to unexpected and potentially malicious behavior. An attacker exploits the vulnerability by recursively calling a function within the contract before its execution is complete. Each recursive call resets the contract state, allowing the attacker to repeatedly withdraw funds or manipulate data. One approach to preventing the reentrancy vulnerability is to change the user's balance before performing any interactions with other smart contracts. Smart contracts on the Ethereum blockchain are written in the high-level Solidity language, which is a set of lines of code. Since neural networks usually take vectors as input, it is necessary to convert the source code of smart contracts into an array of numerical vectors. For this task, we used the word-to-vec model. Word-to-vec accepts a large text corpus of source codes in which each word is represented as a vector in a fixed dictionary. Also, unnecessary stop words were removed from the dataset, which helped to increase the accuracy of the model and reduce the training time. To put it simply, stop words are words that do not significantly affect the semantics. In our case, stop words were the names of variables and functions. We choose a recurrent neural network as a type of network because it was designed to handle sequential data, which is our case, since our task is to classify text data. Unlike traditional feed-forward neural networks, recurrent neural networks have a feedback loop that allows them to maintain internal state or memory. This makes them particularly effective for tasks involving sequences such as natural language processing, speech recognition, and time series analysis. The recurrent nature of the network enables it to capture temporal dependencies and context in the data. When it comes to handling long-term dependencies in sequential data, standard recurrent neural networks encounter a challenge known as the vanishing gradient problem. This problem arises because gradients tend to become extremely small during training. So it makes it challenging to capture long-range dependencies. To address this issue, variations of recurrent neural networks such as long short-term memory and gated recurrent units have been introduced. These architectures incorporate gating mechanisms that allow recurrent neural network to retain important information over longer sequences and mitigate the vanishing gradient problem. Gated recurrent units has a simpler architecture compared to LSTM, making it easier to implement and computationally more efficient. Gated recurrent units also have fewer parameters than LSTM, which can be advantageous when working with limited data or computational resources. Therefore, we applied gated recurrent units in our model. To improve the accuracy of our model, we decided to use bidirectional gated recurrent units. And as the name suggests, they consist of two Garou layers. One processing the input sequence from the beginning to the end, and the other one processing the sequence in reverse. Such architecture enhances the ability to capture contextual information from both past and future time steps in sequential data. In traditional recurrent neural networks, the entire input sequence is usually encoded into a fixed-size hidden state. This approach may struggle with long sequences, as crucial information can get diluted or lost in the encoding process. In this paper, we added the attention mechanism to gate the recurrent units. The attention mechanism addresses this issue by introducing dynamic weighting mechanism. So instead of encoding the entire sequence into a single hidden state, the model assigns different weights to each input element based on its relevance to the current prediction. This way, important information is given more focus. Combining the attention mechanism with the GRU architecture, we enable the model to not only consider the hidden state, but also the attention-weighted context vector. This context vector contains information from specific elements of the input sequence, which aids in making more accurate predictions. At each time step, the attention mechanism calculates attention scores for each input element. These scores represent the importance of each element relative to the current time step. Then, a weighted sum of the input elements using these attention scores generates the context vector, which is used in conjunction with hidden state for predictions. So I would like to demonstrate the overall architecture of our model. It receives the source code of the smart contract as input, then it selects code fragments that could potentially have vulnerabilities and converts them into an array of vectors using vector embeddings. The number of tokens in the vector representation of the contract fragments is set to 100, while dimensionality of the vectors is set to 300. In the next step, these vector representations are passed to the input of the bidirectional GRU layer. After that, a layer with an attention mechanism is applied, the output of which is transferred to the linear layer. This layer has two outputs and uses the softmax activation function. A binary cross entropy was used as a loss function during the training, and Adams gradient descent algorithm was used as an optimizer. The values of learning rate, dropout rate, and batch size are given on the slide. The model architecture based on neural networks was determined to be optimal after a series of empirical research. We used PyTorch Lightning framework for implementation of this model. Smartbox prepared one of the largest datasets of smart contracts with vulnerabilities, and in this paper we used it to create our dataset for neural network training. We selected 250 smart contracts with re-entry vulnerability and the same number without vulnerabilities. Thus, the total volume of the dataset for training was 500 smart contracts. In this paper, we use three main metrics to assess our model, namely precision, recall, and F-beta score. The precision metric describes the ratio of true positive values to all positive prediction. This metric makes it possible to assess the reliability of the classifier's positive forecast. Meanwhile, the recall metric shows the proportion of actual positive results that are correctly classified. The F-beta score provides a more balanced characterization of the model than the precision and recall metrics. The F-beta score is calculated as the weighted harmonic mean of precision and recall. We set beta to equal 2 because F2 measure puts more attention on minimizing false negatives than minimizing false positives, which is more important to us in this case. To confirm the effectiveness of the proposed model, we compared it with several others. The results of the conducted experiments are as follows. As it can be seen in the table on the slide, the model based on a simple recurrent neural network shows the worst results. The model based on LSTM has slightly better performance. In the same time, models based on bidirectional LSTM and GRU are significantly ahead of previous models, due to the fact that the input data comes in both directions. Modifications of these models by adding the attention mechanism also significantly improve the characteristics. The obtained metrics for these models turned out to be close in value. Also, the bidirectional GRU with attention model has a slightly better recall metrics, due to which the F-score increased to more than 91%. So let's move to the conclusions. First of all, a new method for detecting vulnerabilities of smart contracts at the solidity code level was presented in this paper. The proposed method uses one of the modifications of recurrent neural networks, namely bidirectional GRU with an attention mechanism. And we have demonstrated that this model has high performance metrics compared to existing ones. The implementation of the attention mechanism in the network architecture made it possible to focus the attention of the neural network on areas of the code that are more prone to vulnerabilities. The developed model has a higher F-score than the bidirectional LSTM with an attention model, while using less parameters to be trained. This allows to train a neural network to detect new types of vulnerabilities faster, which is especially important in conditions when new vulnerabilities are constantly appearing. That's all. Thank you for your attention, and I will be glad to answer all your questions.
Dear Alexander, thanks a lot for your presentation. Your use all necessary time to present the main results of your paper. And I would like to propose our audience to ask their questions. You can send it using chat of Google Meet or using your microphone, as you prefer. So if you have, you're welcome. You can start. Maybe while you need some time to prepare your question, I would like to start. And Alexander, I have a first question to you. Tell us, please, how do you detect vulnerability of smart contract to prevent invasion? Is it in sphere of your research, or it's your future work, or maybe you have preliminary results of this investigation?
Thank you for question. Yes, we have a preliminary data which was prepared by Smartbox, which is one of the leaders in the vulnerability detection. So it is one of the biggest nowadays datasets which consists of smart contracts with different vulnerabilities, and we collected this dataset and make some data processing before using it in our model. In future, we have an idea to prepare a special script which will automatically generate new smart contracts by injecting vulnerabilities into smart contracts. In this way, we can create a large data sets with thousands of smart contracts and increase accuracy of detection, but it is our future work.
Thank you. And I have a second question to you. Could you please to explain, you demonstrated result of your evaluation, if it's possible, yes, this one. And I would like to ask you, do you prepare, for example, related works or literature review, for example, and what could you say about preliminary previous results? I mean, your results is better or worse than existing ones, or you didn't consider same papers, for example, in this direction?
Thank you for the question. Yes, we made a research on all existing literature in the sphere of vulnerability detection in smart contracts. And the last one model, bigger with attention one, is the exact model which we created by ourselves. The previous one, it is models which were already presented in other literature, and we simply constructed these models from scratch by using the data, the information in that papers.
Alexander, do your results outperform existing research in same field, or on the same field or less, or what you can say?
Yes, our results outperform the existing ones, and it is one of our main conclusions of our work that we gained a very excellent results. As you can see, the L beta score of our model is 91, more than 91%, and the closest value has a BLSTM attention model, which has only about 91%.
Thanks a lot. And my final question, tell me please, which advantages of your means of preventing vulnerability in contrast of existing ones, if any?
First of all, it is the use of gated recurrent units, because this architecture is really advantageous when we are working with very little data collections for data sets. Otherwise, LSTM architecture needs large data sets to be trained fine. That's why our main contribution is that we used gated recurrent units and achieved even better results than results which were achieved in other papers.
Thank you so much. Very clear answers. And I would like to propose to pose the questions from our audience. Maybe some you have some other questions, and you have possibility to pose your questions right now. Chat box is empty. Maybe using microphone, you can ask. If you haven't, then thank you so much, Alexander,
Thank you.
for your presentation, and we will go to our next presentation. So our next presentation is prepared by Yuri Sholomy and Vitaly Yakovina, is entitled Quality Assessment and Assurance of Machine Learning Systems, a Comprehensive Approach. You're welcome.
Hello, thanks. Just 1 second to start the screen sharing. Okay, so I hope you hear me, and I hope you can see my screen.
Yes, of course.
Okay, yeah, my name is Yuri Shalmy. I'm a PhD student at Polytechnic National University, and I'm here like to present our paper together with my supervisor, Vitaly Yakovina, entitled like Quality Assessment and Assurance of Machine Learning Systems, a Comprehensive Approach. This is a presentation of ideas into PhD research project on quality assessment and assurance of ML systems. So the research itself is ongoing. It's at early stages. And the purpose of our paper that I'm going to present is to justify this PhD research on quality assessment and assurance of ML systems. The project itself is based on the foundational hypothesis that existing software quality models and methods like a comprehensive approach to bias in production ML systems. The project's goal is to research the problem of bias detection and prevention in production ML systems, and also to develop a comprehensive approach that would bridge identified gaps in existing quality models and methods. The structure of the presentation is as follows. It has 6 major sections, and I'm going to present them in the following order. First, we're going to look through the research background and research questions. Then I will articulate the importance of the research as well as the approach to cover it. And of course, I will have a look into the threats to validity, explain what are the potential and expected threats to validity of the research, and a sneak peek into the planned experiments throughout the research. Yeah, because as I said, research is currently in an early stage, and the research and experiment roadmap is being actively considered at this moment. So let's start with the research background. When we are talking about machine learning in production specifically, there's an interesting observation that mostly when we're talking about quality of ML in general, machine learning systems, there's a lot of research and a lot of attention to metrics of ML models. For example, accuracy, precision, recall, S-score, etc. All the things they are, when model is developed and model is prepared, this is what is usually used to value whether the model is not ready for production, for example. But as production use shows, sometimes model could show great accuracy, great, precision, recall, etc. All metrics are far above than 90%, for example. But for some reason in production, the system doesn't provide good quality. For example, it makes mistakes, it makes unfair decisions, it does misclassifications, it misses its objectives. And this an interesting question because metrics shows that the model is good, but unfortunately in production, the results are not that good. And together with my supervisor, we observed numerous cases in both in industry and also in academic research related to this, that model trained in lab environment doesn't work good in production environment. And we question what might be the reason. And of course, the first and the most obvious place to look at is the nature of the ML systems itself. A research by a paper by Scully of 2015 at Google, they showcase that mostly when we're talking about ML in production, preparing an ML model is not enough. It's in fact a huge system around it. We need a lot of additional code to write to make ML model running in production. In other words, when we are talking about machine learning in production, that is not just a model, it's also a lot of things around it. Needed to train it, needed to operate it, needed to check the results, etc., and needed to build in it. So things like ML ops and other things that emerge currently to help this process in production. But generally speaking, when we're talking about ML in production, what I would like to highlight, it's we're speaking about ML system, not just machine learning model, but a system around it. And this brings, this systematic level or emergence, systematic emergence, emerges new characteristics which are inherent to the system level, not just a component level. And related to the nature of machine learning and machine learning systems specifically, one, first and foremost, is of course data centricity, especially when we are talking about supervised machine learning, which is, by the way, the primary focus of our research is supervised machine learning specifically. By data centricity, it's also known as data dependent behavior. It's first and foremost an inherent characteristic of ML systems. And it reflects the central role that data plays in development, performance, and function on the systems. Unlike traditional software components of software systems where instructions are written by humans and they're explicit, they're designed, ML components, they learn their operability, or they run these rules from data, and actually they reflect the data. And this data centricity is a potential and most looks like a most viable reason for biases, for example, in ML systems decisions, because if we have biases in data set, which was used to train the ML model, they will be prevalent in the ML model, which was trained on based on that data set. And the problem with preparing an unbiased ML data set or data set to train an ML model is that the human nature is biased by itself. So when we want a software system to be unbiased, we need to look at ourselves, whether our own decisions and experience are unbiased. So data centricity is one of the major drivers of ML inequalities in production. Another one is, of course, uncertainty. This is related to verification and validation of quality, because when we write code, there are methods that we could verify the system, like formally, formal verification of traditional software, which could not be applied to ML components specifically because, yeah, again, due to data centricity, they're not predefined instructions upfront. They utilize data relations, interrelations in data components to make their predictions. In other words, we cannot foresee, in some cases, which would be the answer of the model. And of course, another characteristic which would make ML systems different from the traditional software runs is, of course, the complexity, because to train and operate an ML model as a part of a larger software system, you would need additional boilerplate code, you would need additional pipes, how it would be called, around it in order for this component just to operate. And this introduces this additional complexity to the system, which again makes it harder to evaluate its quality, and make sure its quality is achieved. Regarding the quality assessment and assurance challenges related to these unique characteristics, we may name a few. Of course, data quality, this is a major challenge. Like the previous presenter showcased, that to prepare a bigger data set, we sometimes need to utilize generative methods or just prepare the data set, because for some of the models, for some use cases, there are just no enough sufficient data sets naturally occurring, and we need to artificially create them to complement the model. And this also raises the question whether this artificial creation of such data sets doesn't introduce a bias, and whether it covers the matter of things in the real world. That's open up an important question. Worse, bias and fairness, and bias is, by the way, the focus of the research. Bias and fairness are things that mostly are visible by end users of such systems. For example, when algorithms of photo categorization mismatches or misclassifies photos, and this might introduce unfair classification, especially when we are treating evaluation of photographs, for example. Or maybe when we utilize a credit score model, which unfairly treats specific groups of people. And by the way, by fairness in general, I do not refer to fairness just in terms of the social thingy. It just, any class of data could be like unfair. It's not related only to humans. It may be just misclassification of whatever, or specific classes of details in manufacture, for example. Some of the other challenges include interpretability and explainability of these models. This related to the uncertainty as a unique characteristic of such systems. Some models, especially deep learning ones, are really hard to interpret and explain. Either to explain how they work, or on the specific data set, or how they come to a specific conclusion in those cases. And depending on the complexity of the model, it may be harder and harder. Again, this brings challenges to evaluate the quality and ensure it. Trustworthiness is something referred to as an encompassing quality characteristic of ML systems, which is not currently like defined as some kind of a metric or whatever. But when we refer, could we trust ML systems? We could refer to it as that way. And under this trust, we could mean everything. It could be accuracy in production setting, of course. It could be fairness. It could be unbiased decisions, etc., etc. So it is like an encompassing quality characteristics, which currently, unfortunately, I mean, it appears more and more in papers in industry. Well, unfortunately, we lack sufficient means to evaluate and to assure it. And of course, robustness and security is some additional challenges due to the unique characteristics of ML systems that we might want to have a look at. The research questions of our PhD project could be formulated as follows. The first one is, to what extent do biases in ML components lead to incidents in operational ML systems? This is basically, I mean, since our PhD project is mostly related to the bias as a focus of research, we would like to check our hypothesis that bias is one of the major problems in terms of quality of ML systems. The next step would be to answer the second question is, where do the current quality assessment models and methods fall short in addressing bias detection in production ML systems? And the third question to address would be, of course, what gaps exist in current quality assurance models and methods when it comes to preventing bias in operational ML systems. The importance of the project could be summarized as follows. Biased ML systems can lead to poor decisions, which can tarnish the reputation of businesses and erode user trust. As ML systems becomes more integral to many sectors, regulatory bodies, all you know that the European Union Act on AI are increasingly concerned about bias specifically, and not only bias, by the way. And as ML systems increasingly influence decision-making in sectors like healthcare, finance, and justice, it's crucial that these decisions aren't affected by biases. Our approach to the research has four major pillars. The first one is to quantify the prevalence of bias-induced incidents in operational ML systems. The second step, a pillar, would be to analyze the gaps in existing software quality models and methods related to bias detection and prevention. Then we intend to propose an improved approach to quality assessment and assurance to address the challenges associated with bias in ML systems. And of course, the summarizing pillar would be to evaluate the proposed approach in a few case studies. Potential threats to validity of our research are, of course, the definition of bias in ML systems, because currently quality models for ML as a kind of software systems are only being developed, and ISO standard only this year published the first version of the ISO standard extension. I mean, ISO 25010 related to software quality, with some additional characteristics which are related to AI. That, of course, under AI we understand ML as well. So it's emerging field currently, and potentially what we would be looking for would not be considered a bias just in general terms. So definition is important. Data sources for production ML systems incident research. So as I said, we would like to quantify this prevalence of bias in production ML systems. We are going to use a data set which was collected by open source contributors related to incidents with artificial intelligence systems in production. And of course, our research studies would be highly based on the quality of this data. Selection bias of existing software quality models and methods also would affect the results, because when we would evaluate what currently exists, we may omit something which exists, which would cover the problem we look at. And of course, criteria and metrics used to evaluate quality models and methods. Again, this is something that is a potential threat. And to summarize the threats, generalizability and temporal relevance of the proposed approach is also one of the major threats related that we should be careful with. And I would like to conclude my presentation with just a draft version of the experiment roadmap throughout the project. So first and foremost, the first goal, first task is to evaluate quality models and methods against controlled and real-world data sets to assess their efficiency for bias detection and prevention. So this relates to existing quality models and methods, and of course, suggested one. And of course, case studies to evaluate the suggested approach to quality assessment and assurance focused on bias detection and prevention. This is it. Thanks for your attention. I'm ready to answer questions.
Thank you. And now our session chair, dear Tommaso, your floor is yours, so you can continue. You're welcome. Please.
Okay. Yes. Good afternoon to everybody. I really apologize. I made a mistake with the hour. I was I connected just now because I thought that it was at 1:30 your time, and okay. So sorry. I really apologize. Let me say also one quick thing. It's really an emotion for me to interact again with researchers from Ukraine. As you can easily understand, is really an emotion for me. And now that the presenter has finished, I would forward to him but I don't see in the chat any question. Are there questions? Are there comments about this presentation?
I have. Could I start?
Please, Vitaly.
Thank you, Tommaso. So I have some questions to your presentation. Thank you so much for your presented approach and for actuality of your research. And my first question is, which trade-off, what do you think exists between different quality characteristics which you introduced? Can we to reach them simultaneously, or maybe we can use some priorities among them, and for example, we can neglect some of them during the process of estimation?
Okay, thank you for the question. Sure, this is a very good point, because all quality models that currently exist, even for traditional software, they do not cover the trade-off question at all. And this is something usually addressed additionally, because quality models, they define what would the quality is, how to measure it, some metrics, additional characteristics, etc. But they do not showcase these trade-offs, as you correctly mentioned. So from the perspective of ML systems specifically, of course, the trade-offs could be connected with accuracy, if I can call it in general, and, for example, interpretability and explainability. So the complexity of model is not like directly related to the quality it produces, but in general, when we're talking about correct decisions or predictions made by a model, usually we need to complicate the architecture of the model, especially when we're talking about deep learning. And this would definitely reduce interpretability and explainability. So this is kind of a trade-off, because if we want a better quality, we would complicate the model in most cases, and this would reduce our understanding of how it works. That's one of the cases. And of course, this would affect additional quality attributes into these trade-offs, like trustworthiness, because if we cannot explain how it works, we cannot trust it.
Thank you. And I would like to ask one more question, which is connected maybe with previous one. Can we combine, for example, interpretability and predictability using machine learning methods, or maybe it's impossible?
This is good question. I don't have an answer right for this. I think this is one of the directions of our research to evaluate currently existing methods to, for example, specifically to bias, how to detect and prevent it. And the bias detection models and methods, for example, we're currently being researching that this specifically, I mean, I'm not ready to share the results of them. We are only starting our research in that direction. But I think there's a potential in that direction. But I mean, I cannot say for sure because I don't have results of my research by hand currently. But I think that is possible.
Thank you. And my last question, if possible, about start of your presentation. You told what we can have a training set and very good accuracy of the model. But when you use, for example, a test set, then accuracy is very low compared to training data set. The question is, what is the main reason of this result, and how maybe we can mitigate these consequences, and how we can use machine learning methods to minimize this difference between accuracy of training and test data set.
Okay, thank you. I would like to narrow down the question a bit because I believe I didn't mention it specifically, but when I explained that, I meant that both testing and verification of ML quality, like in lab environments, they show good results. In other words, we take a huge data set, we split it into train, test, validate, and model works good on this data. But when we deploy it to production, it doesn't work. I mean, it don't show that good results. This was specifically what I mentioned. So it's not like when we train model, test results are good, but validation data set shows problems. No, specifically that model is trained specifically on a data set it was prepared for, tested and validated. And the question is not even to the model itself, but to the data set. That's because we take training, tests, and validation from the data set we have when we develop a model. And when we deploy it to production, the major problem that I would assume is this lab to real world mismatch in data. I mean, or it could be called like model real world gap, because when we collect data to train a model, to validate it, to test it, we may not collect everything. We may ignore some classes. For example, the classification of images, we just may not represent some of the class of images enough, or underrepresented or overrepresented another one. Like there was one production case when the risk score engine decreased the credit score for women specifically, because when the model was trained, there were more cases, or not cases, but there were more data samples to men and not to women. And this, as a result, I mean, tests show that the model accuracy was fair, it was good enough. The model was deployed into production. Unfortunately, it underestimates the capability of women specifically to take credits in the banks. So what I'm saying, the major problem with this is not specific. I mean, the problem is that, for example, metrics like for example, F-score, they might not show the quality of the system in the real world. So in lab environment, it showcases that the model works good on the data set it was trained on and validated on and tested on. But in the real world, it might have a problem. So our focus of research is to research and find the solution to this problem, how we could see that model which shows good accuracy, but we may evaluate it would not be good in production because it doesn't cover, I mean, the statistical coverage is not sufficient, for example. But it's really a simple one because we like to evaluate this at a system level. So the problem is not like the mismatch in train, test, and validate, but versus lab or development environment versus production one. And also one small thing I didn't mention about is naturally real world evolves. It's not static. So in other words, when we train a model, we deploy to production. At first, it may operate and provide good results, but such thing as a data drift, temporal data drift, might render this model like it may decrease its quality, as we could call it in general. And also, our assumption is that we currently lack sufficient and sophisticated models and methods to catch this data drift.
Thank you so much.
Okay. So, I haven't attended your just the end of your presentation. So, but I would have some comments on your paper. But I think we are running a bit out of time because now we have. It's time to introduce the third presentation. I don't see other questions in the chat, so I think it's time to introduce the third presentation. Thank you, Yuri. Thank you again. Virtual cheers for you. Thank you for your answers. And now it's the turn of Lilia Fadieyeva. Sorry for my pronounce. I don't know how good it is. She will present a research titled Bibliometric Analysis of Adaptive Learning Literature from 2011-2019, Identifying Primary Concepts and Keyword Clusters. So, quarter hour for you. Please, the floor is yours.
Everyone. Do you see my presentation?
We can see it well. Please proceed.
Okay. I am Lilia Fadjiyeva, the PhD student from Kryvyi Rih State Pedagogical University. The goal of my research is to develop a methodology of adaptive learning for the university students in the conditions of blended learning during crisis. Since 2020, with a widespread of the COVID-19 and especially since 2022 with full-scale Russia's invasion in Ukraine, the Ukrainian teaching staff challenges in performing and managing emergency distance education. This raised both technical and organizing issues, which made drastic changes in the Ukrainian educators' digital competence. For the first time, the educational community has been self-organized to prevent disruption of education on all levels, from preschool to tertiary. There is a growing interest in more flexible, innovative, and sustained models of professional development. In addition, the emergence of new technologies such as artificial intelligence and large language model, mixed reality, and social robotics challenge educators and requires them to take a more active role in the design and implementation of the teaching aids and learning tools. To ensure their use will prevent a disruption of education in effective and cost-safe way. Overall, there is a need to develop and test new pedagogies and techniques, also by investigation how emerging technologies can be smoothly integrated in exciting teaching and learning practice. One of the prominent applications of artificial intelligence in education is technology-supported adaptive learning. At the beginning of research, bibliometric analysis was conducted using the WOS viewer to systemize available scientific knowledge. In order to carry out the analysis, a selection of sources from the scientometric database corpus was made upon request. Adaptive learning in the titles of articles, chapters, or books, and social science in the subject area. As a result, 344 documents were selected, and their distribution by year is presented in the slide. Cluster analysis by keyword occurrence was conducted from 1,836 keywords were selected that appeared at least 10 times. The result of the cluster analysis is presented in the slide. According to the feature, keywords were divided into 5 clusters. The first cluster, red color, includes 12 keywords, 5 of which are primarily related to adaptive learning theory, adaptive learning, adaptive system, curricula, learning style, learning experiences, learning algorithm, and personalization. Other concepts are related to adaptive testing, item response theory, implemented in e-learning systems that operates with learning objects and can be automated by means of artificial intelligence. The second cluster, green color, contains 7 keywords related to the practice of computer-aided instruction of students and adaptive learning environment. The third cluster, blue color, contains 5 keywords that describe the implementation of learning process within engineer education by means of education computing. The fourth cluster, yellow color, also includes 5 keywords that describe the didactic fundamentals. The fifth cluster, violet color, consists of only keyword personalized learning. This slide represents the keyword density. According to visualization, the keywords adaptive learning, learning system, students, and e-learning have the highest density. These items are the most interconnected. To determine primary research concepts in their development, in slide is presented overlay data visualization by years. As you can see, most concepts emerged after 2000 year. Also, there are no fundamentally new concepts that have occurred since 2020. This and related visualization give us grounds for limiting the analysis years. After a series of years limited studies, the bibliography analysis was conducted using documents from 2011 to 2019. And now you can observe a more clear distribution of research concepts by time scale. From this slide, one can see that concepts of human education and learning objects are emerged earlier. At the same time, adaptive learning and artificial intelligence concepts became disseminated later than those related to the use of information and communication technology in education. Several important conclusions resulted from the bibliometric review. To begin, the research focused on publications from 2011 to 2019, a period that showed a large increase in interest in adaptive learning. Using cluster analysis, the study successfully identified the research problem domain. Adaptive learning, learning system, e-learning adaptive system, learning objects, learning style, learning algorithm, students, computer-aided instruction, adaptive learning environment, learning contents, adaptive learning system, education computer, engineer education, learning process, education, teaching and personalized learning were also established as key concepts central to the subject. The result of the bibliometric analysis have provided valuable insights into the current state and emerging trends in adaptive learning literature. Building on this analysis, several areas of future research can be explored to advance our understanding of adaptive learning and its application in education. Thank you for your attention. Any questions?
Thank you, Lilia. Thank you, Lilia. You have been really, really effective in with your presentation. You said about 5 minutes that we can spend for questions and answers. I don't see any question into the chat. Are there any questions, comments? Don't forget that we are at PhD Symposium, so every comment, every question could be really helpful for young researchers.
Could I
Please,
start?
Vitaly. Yes, please, Vitaly.
Thank you so much. Thank you so much for your presentation and for demonstration of the main results of your research. And I have some short questions about your presentation. The first one is which methods of clustering did you use, and the reasoning why do you use exactly such methods?
Thank you for your question. I using the WAS viewer for clustering, and I use tools.
Can you remember maybe which one?
Sorry, one minute.
You're welcome. If you don't remember, it's no matter.
Yeah, I use WAS viewer for clustering and tools for WAS viewer. It was the default tools.
Okay, but do you remember methods of clustering? Maybe I didn't heard you in your answers. What methods of clustering did you apply for your data?
I use co-occurrence methods for clustering.
Thank you. It's enough. And my next question is, why do you select 5 clusters? Why not less or not more?
This cluster was built in with tools at least 10 times. 10 times keywords appeared in articles. And the number of clusters can be decreased or increased depending on the clustering settings. An example, the third cluster can be combined with the fifth cluster. Third cluster, blue color, can be combined with the fifth cluster. That only has one keyword, personalized learning. But I don't want this.
So it was your maybe assumption to use 5 clusters, or you experimentally, for example, you start from 2 clusters till 3 clusters, 4, and after that you have, for example, only one element in one cluster, and you decided to stop.
I experimental do 4 cluster and decrease number of cluster, but it's not clear on the map. So I leave 5 cluster.
Okay, and I have maybe for me the main question. Could you please to tell how can you plan to use this cluster analysis and your future research? What's your main goal to select these clusters, and what's application of results of your cluster analysis?
This research can help me this research can help me
maybe to start literature review of your future research.
Future research. I plan to provide the systematic review, and on the future also it helped me the set direction how adaptive learning and how interconnected adaptive learning and other concepts in scientific literature.
I understand. So you try to find your research question for your future, for example, PhD research.
Yeah, it's helped me to find research question.
Okay, thank you for your answers.
Thank
I
you.
have
Thank
no.
you. Thank you, Vitali. Are there any other questions? Okay. While waiting, I would encourage you to submit questions or comments. I would have a couple of comments for you, Lilia. First one is about your start, because you say that you systematize available scientific knowledge, but it's a bit unclear. Yes, and you made a search on Scopus and other databases, but it's a bit unclear. If there were some limits to your search or not. If you were searching only on certain fields or not. This is my first question. And my second comment is about your query, because you said that you searched only one term, adaptive learning, only in titles of the papers or books or chapters, etc. This sounds a bit restrictive as a query, because, as you know, very often scholars use tactics to distinguish their works, their papers. So they use different words, some maybe catchy word in their title, and maybe adaptive learning could be into the abstract or into the keywords. So usually these kind of queries are addressed to not only to titles but also to abstracts and keywords. So I would ask you if is there a special reason for doing this, or this is just the first step and you can do it again, maybe with enlarging a bit these constraints. I don't know, please.
Thank you for your question. I use only one term, adaptive learning,
Okay.
for searching literature, and only title, because its term widespread, and is consensus around this term, and also using a single keyword can help to reduce the number of false positive in the search result that might be retrieved when using multiplying terms. So this is also for title, because if I search adaptive learning in keywords annotation, very a number of articles, many articles was false positive. They are not relative to adaptive learning. How I can
Thank you, Lilia. I would have another couple of questions. The first one is more or less linked to something that Vitaly was asking before about your cluster method. There is something a bit strange in your clusters. The fact that personalized learning is a cluster per se, with a single keyword, which is however closed to other keywords, both in terms of sense but also in terms of position. So is there a specific reason to keep it as a separate cluster, or is just something that you stopped at this moment without you decided to stop there without a specific reason? Because if you read all the other clusters, there is a common sense to all the words that are gathered into one cluster. There is a clear common sense, and while in this case we have a single word isolated, which looks a bit strange, unless there is a strong reason for this. Personally, I would have gone for some other iteration, or I don't know. Please.
Okay. Why 5 clusters?
Yeah, well, why a cluster with a single keyword, which, by the way, hasn't by the way, appears not, there is always the intelligence of the researcher there, also to judge if the clusters are make a sense or not. So there is this keyword which looks close to the keywords of the green cluster, but is isolated. So is that just because you stopped there, or at that iteration, or is there any specific reason for keeping these isolated?
Okay. Thank you for question. 5 cluster because I changed tools during clustering, and keyword personalized learning combined with cluster blue color. It's education, computer, and learning process, adaptive learning system, and engineer education. And I think that some different keywords and some different topics of these researches, some learning process and education computer and personalized learning, very different keywords. So I think that 5 clusters is optimally number.
Okay, thank you, Lilia. I would go for my last question. I don't see questions in the chat, so while waiting for some questions or comments, I would ask you to go to the conclusions, because there is you write something that was unclear to me also when reading your paper. I would like you to say something more. Can you get to the conclusion slide?
Yeah.
Okay. So here you write, with the help of cluster analysis, the problem field of the research was determined. What do you mean exactly with this?
Determined.
What do you mean? The problem of field of the research was determined. So the cluster analysis, in some sense, with the cluster analysis, you have a map of the distribution of keywords on previous literature. But what do you mean for the problem field of the research was determined? Is that your field of the research, and in this case, which kind of field, how it has been determined? Can you say something more?
I mean, was determined the problem field for my future research because I write a PhD thesis, and this study helped me determine the gap in scientific area.
Which gap exactly?
With cluster, with the cluster, I can see how different keywords connected with other, and what keywords are more similar field and what field I don't need.
Thank you, Lilia. Thank you, Lilia. We have now at the end of this session. I don't see questions anymore, but we are running out of time. So thank you, everybody. I apologize once again for my big mistake with the time. I have no words for this. So I wish you all for this very interesting session with 3 different papers on 3 different topics using different methods. So a lot of variety, very interesting, at least in my opinion. So I wish you all. Thank you all for your attendance. I thank the presenters for their presentations, and so I will close this way. My best wishes for you all from Rome.
Thank you so much, dear Tomasa, for your sharing. We are very glad to see you on our event during last years. It's very helpful for us, and we are very happy what you have a possibility to join to us during our conference. And taking into account some seconds what we have, I would like to invite you on our next session through the 30 minutes, which we will proceed on our next slot in the conference. I'm very happy to see all participants of this section here, and I wish all of you successful and interesting continuation of our event. Thank you so much. Thank you.